Alright, now that we know how to work with square roots, especially square roots of perfect squares, or radicals of perfect squares as we sometimes say, now we're going to talk about finding roots of perfect cubes. Finding roots of perfect cubes. And as a warm-up, again, we've got to have some of these perfect cubes memorized. So 1 cube, that would be 3 ones multiplied together. That answers 1. 3 threes multiplied together, that would be 27. 3 fives multiplied together, that's going to be 5 times 5 is 25, times another 5 is 125. 2 cubed, remember that's 8, and 4 cubed, 4 times 4 is 16, times another 4, that's going to be 64. Again, you can see what I mean by when I said if you've got those memorized, that's just going to make things much quicker. So make sure you've got those memorized at least up to 5 cubed. That's going to make things a lot better. Now remember the terminology, the vocabulary that we need for this. We're talking about radical, radicand, and the index. So that right there, that funky symbol is the radical. That number underneath is called the radicand, so radicand. And then this is the index. Now, when we were doing this before, we didn't have an index, and we said if there's no index, we get to assume that it's a square root. Any other type of root, they've got to put the index in there. So let's take a look at what we've got right here. Again, the index tells us what root we're trying to find. So if it looks like this, if this is a 3 right here, then that's telling us that we need to find the cube root. If it was a 4, we'd be finding the 4th root. If it was a 17, we'd be finding the 17th root. Luckily, we don't have to do any of those. Okay, but this is called the 3rd root, or the cube root is what we say. So if the radical 25, if the square root of 25 is asking what number squared gives us 25, remember that radical is asking a question. Okay, if the index is 2, it's asking for the square root. So what number squared gives us 25? Then the cube root of 8 is asking this. It's asking what number cubed gives us 8. So let's take a look at this right here and let's figure out how to do this. It's asking what number do we cube in order to get 8. Now if you've got them memorized, then you're in good shape. You can probably just write down the answer, but let's talk about why. So this is the cube root of, let's write down what number we'd have to multiply by itself repeatedly. If we did 2 times 2 times 2, we've got 3 2's. This is 2 to the 3rd. So what number do you cube to get 8? You cube 2 to get 8. So the answer on this one is 2. So taking a cube root changes a group of not 2 factors, but 3 of the same factors inside the radical into 1 factor on the outside. So unlike up here where we were doing this was 5 times 5 times 5, remember the exponent changes this base into 3 factors right here. We're kind of doing the exact opposite, and if you kind of keep that in mind in the long run, you're going to be in much better shape. Okay? So again, it's important to think about how many of the same factors you're looking for on the inside, because that's how we're going to simplify more difficult radicals, more difficult roots later on in this unit, later on in this year, and really in all the math classes you take from now on. Okay, you're also going to be simplifying radicals in most math classes that you take, so we want to keep in mind how many of those factors are we looking for. Now, there's something interesting about this one right here. This says the cube root of negative 27. So this is asking what number do we cube to get negative 27. Now, I'll let you think about that for just a second. The number should look really familiar. If it were just a plain old 27, we could do 3 times 3 times 3. In fact, I'm going to put all of those in parentheses. Okay, but that would give us a positive 27. Now, there's something cool about when we multiply something by itself 3 times. If we made them all negative, we've got 3 negatives. We've got an odd number of negatives, so that would give us a negative 27. So if the number underneath the radical, if the radicand is negative, the answer is going to be negative, and then you can just figure out what the cube root of 27 is. What number do we cube to get 27? It's 3, so there's the answer right there. So on this one right here, if the radicand, if the number underneath is positive, the answer is going to be positive. And again, up above in the warm-up question, we answered this right here. What number do we cube to get 125? We cube 5. And again, if you've got those memorized, it's just going to make it a heck of a lot easier. I'm hoping you've got this one memorized. The number 1 is a perfect cube, it's a perfect square, it's a perfect 4th power, 5th power, and so forth. So what number do we cube to get 1? That would be 1. Okay, and then the same property that we talked about yesterday that works with square roots works with cube roots. So we can find the cube root, and don't forget to put the index, cube root of 27, and put that over the cube root of 1000. We did this one just a second ago, so this one is a 3. And the cube root of 1000, remember, that's got 3 zeros in it, so that would be 3 tenths. So this is going to be 3 tenths. Again, we go from this really ugly looking expression to just the fraction 3 tenths, so not too bad. Keep in mind that this one's negative, so our answer is going to be negative. Let's do the bottom first. Cube root of 64. That one looks familiar. 64, that was on the list that you should have had memorized. Yep, 64. We cube 4 to get 64. So I'm going to put a 4 on the bottom, and then this one right here, I'm going to let you take a look back on your list that hopefully you've still got floating around. We need to know what number cubed gives us 343. So take a look on your list. It is 7. Okay, so we're going to circle that and we're done. Again, the key here is I think the easy part is understanding how these radicals and these square roots and cube roots work. If you've got them memorized, especially when we're talking about perfect squares and perfect cubes, because that's all we're going to give you on this assignment is just perfect squares and perfect cubes, you should be in really good shape. What we're looking for, I think, is a pretty easy idea. Now, if you've got questions, please make sure you ask, but that should be enough that you can do today's assignment. Good luck.